Hi, so today we're going to talk a little bit about the periodic table and what you can actually learn about an atom from its placement on the periodic table. So some things that we need to know and understand. The horizontal rows of the periodic table are called periods. So periods, that's like a repeating thing. So what we're looking at is like if we just had a bunch of random elements, we could just list them like in rows. We could just like make a big list, but we have them in this table for a reason. So every time you have a row on the periodic table, there are a certain number of elements in that row, and then we go down the next element after the last on the right of that row would be in the next row. And there's a reason for that we'll find out in a second that deals with the energy levels in the atom. So an energy level is where we have those electrons, where those electrons are placed around the atom. Are they closer to the nucleus? Are they in the first energy level, or are they far away from the nucleus? That would be a higher energy level. They would have more energy there. Think about how like masses are attracted to each other, and like the higher you go up above Earth, the more potential energy something has, the more of an ability it has to fall. So electrons are kind of the same way. They're attracted to the nucleus, but the farther they are away from that nucleus, the more energy that we say they have. So on the periodic table, those vertical columns, those are called groups. You might also hear them called families. And the vertical columns, the groups, correspond to the number of valence electrons. So we also need to know the term valence electrons. Those are the electrons in the outer energy level, the electrons with the highest energy for an atom. So if we look at our periodic table, the way this works is that every time those electrons go into another energy level for an atom, we put that atom on a different row, a different period of the periodic table. So things in this first row of the periodic table, hydrogen and then helium, they only have one energy level. Their electrons are just in that first energy level. But by the time we get to lithium, beryllium, all the way up to neon, they hold their electrons in the second energy level also. By the time we get down to sodium, we have to add another energy level. So the third row, the third period of the periodic table, atoms will have 3 energy levels there. The columns, though, if you look at each of these columns, if you look at the outer energy level, column 1 on the periodic table has 1 valence electron in the outer energy level. So everything in column 1, if we look at the outside energy level, it only has 1 electron in that outside energy level, 1 valence electron. But then if you look at column 2, group 2, then those outer energy levels, there are 2 valence electrons there. Group 3, now it's not really group 3 if you look at the whole periodic table. We have this big break in the middle with transition elements. But if you are looking at the Roman numerals and you look at the A groups at the top of your periodic table for physical science, then you'll see that Roman numeral 3A is the number over boron and aluminum. And those will have 3 valence electrons in the outer energy level. And so on all the way until we get to this last column. So this last column is kind of special. Most of these elements will have 8 valence electrons, 8 electrons in the outer energy level, and that means their outer energy level is full. However, helium here only has 2, but the reason it's placed over here in column 8 is because it has a full outer energy level. This first energy level can only hold 2 electrons, so it's kind of a special case. Helium is an exception to a lot of things. In general, though, this last column, all the way on the right, will have 8 valence electrons. So these diagrams that we're looking at right now are called Bohr models. They show all of the electrons in all of their specific energy levels. We map them out like 2 in the first, this one has 8 in the second, this one has 8 in the third. So if you think about that, well, which element is this? We've got 3 energy levels here, so it must be on the third row of the periodic table, the third period. And then these 8 electrons are on the outside tell us that it's in the far right column. So if we go back to our periodic table on the last slide, then we must have something in row 3, period 3, all the way on the right. So we would have the Bohr model there for argon. A lot of times we don't really care about all of the electrons and all of the different energy levels. So instead, what we're really looking at when we look at chemistry, we're talking about these valence electrons. They're the most important to us. So instead we have this shorthand, and we call that our electron dot diagram, or sometimes Lewis dot diagram or Lewis structure. And that shows the element symbol only with those valence electrons. So only the electrons in the outer energy level. And if you noticed in our periodic table, our maximum for that outer energy level, that far right column that had the most, the number was 8. So we can only have up to 8 of these. So if we want to figure out, how many valence electrons would we draw for an element like lithium? Well, we've got to look at which column lithium is in on the periodic table. So if you find lithium, symbol Li, it's in the first column on the periodic table. That means it only has one little valence electron. That's it. But if you look at oxygen, so oxygen is in, well, group 16 if you're looking at like just numbers, or 6A if you look at those Roman numerals on your periodic table, and that means it has 6 valence electrons. So we put 6 dots around oxygen. There is kind of a special way to do this, but for now we'll just go with this to show those 6 valence electrons. Then let's look at xenon. Now xenon wasn't in our short little periodic table with the Bohr models before. Xenon is farther down on the periodic table. So if you find xenon, it's in the far right column. And if we want to know how many valence electrons that has, it's in group 18 or group 8A if you look at the Roman numerals, which means it has 8 valence electrons. So I'm going to go around and put one on each side and then double them up, 5, 6, 7, 8 to draw my 8 valence electrons for xenon, because xenon has a full outer energy level. So to go over what we've learned today, we've looked at rows and periods of the periodic table, how those rows or periods are row number 1 has 1 energy level. Period 2, there are 2 energy levels. Period 3, 3 energy levels for all the atoms that are in that period, in that row. And the groups or the columns of the periodic table tell you how many valence electrons are in that atom. So column 1 would have 1 valence electrons, 1 electron in the outer energy level. Column group 2 would have 2, and then if we skip that middle block of the transition elements and go over to boron, group 3A or group 13, those have 3, and then 4, 5, 6, 7 until we get to that last column where they all have 8 except for helium, because helium's our weird one. I hope you have learned a little bit from this video and figured out that the periodic table is actually a super handy tool for figuring out some things about atoms. All right, have a great day.